Hey everybody. So today we're going to take a light look at the light independent reactions, also known as the Kelvin cycle. So just a couple of notes on the Kelvin cycle. This process is going to happen in the stroma of plant cells, or of the chloroplast, excuse me. So it's going to be in that liquidy fluidy part of the chloroplast. Okay. And this process is going to use the products of the light dependent reaction to help us form glucose finally in the end. And you might notice that you don't see glucose on here quite yet, and that's because we have to run through the cycle. Okay? So if you are still confused on how the light independent reactions work, this is the video for you. If you have any questions about the reactants and products and how they work together from the light dependent reactions to help us form glucose, I have a separate video on that, so that might be where you want to be. Okay, so let's get this party started then, shall we? Alright, so the first thing that's going to happen in the Kelvin cycle is that we're going to have CO2 get added to the cycle. Okay, so one carbon molecule is going to make its way in. Okay. And what it's going to do is meet up with this 5-carbon molecule. And this 5-carbon molecule and carbon dioxide are going to join together to form this 6-carbon molecule that we have here. Okay, so just simple math there. 1 plus 5 is going to give us 6. Okay, then this 6-carbon molecule is going to start its way through this cycle, and it's going to get bombarded by first ATP, and then secondly NADPH. Okay? And ATP is going to give off one of its phosphates, so it's phosphorus, and it's going to be left with ADP. Okay? Then NADPH is going to give off one of its electrons and give us NADP+. So these two energy carriers donated energy to the 6-carbon molecule to split it into these two 3-carbon molecules that we're going to see right here. Okay, so one of these 3-carbon molecules is going to leave the cycle, while the other one is going to continue on through the cycle. Okay, now the one that is continuing on through the cycle is going to meet up with ATP, and ATP is going to bump into it and be converted again to ADP. Okay? And then this transformation is going to happen where this 3-carbon molecule is going to be turned into this 5-carbon molecule again. So we're going to go from a 3-carbon molecule into a 5-carbon molecule. All right. However, you may have noticed still that we have not completely made glucose. So we are going to need to go through this process one more time. Okay, so if we reset everything real quick, we are going to have, again, what's going to happen is our carbon dioxide entering into the Kelvin cycle, meeting up with the 5-carbon molecule to give us this 6-carbon molecule again. Okay, ATP is going to run into it, giving us ADP and donating one of its phosphates, so we are left with the ADP. Our NADPH is going to come down, hit the 6-carbon molecule, donate one of its electrons again, and give us NADP+. This again splits our 6-carbon molecule into 2 3-carbon molecules, and again, one is going to leave, while the other continues on to be made into a 5-carbon molecule with the help of ATP. Okay. Now, the thing about the second reaction is that now, or the second time through the cycle, is that we now have 2 3-carbon molecules on the outside of the cycle. Okay. These two 3-carbon molecules are going to together form one glucose molecule. So, in the light independent reactions, or the Kelvin cycle, we have to go through this whole circle twice in order to get one glucose molecule, because only one 3-carbon molecule is going to leave at per turn of the cycle. Okay, so that is our light independent reactions. This is what you're going to have to do if you were gone and missed this. This is the modeling activity that you guys will be doing. And if you are confused, hopefully that helped just kind of visualize once again the turning of this process and what's happening when, and as well as why. Okay, if you guys have any questions, just email me or come in anytime. And I hope that you guys have a great day and a great week. Bye, everybody.